We've talked a lot about the geometric series, talking about whether or not it converges and the interval and radius of convergence. Here we're going to start talking about the geometric series as a power series and apply it to be able to find functions that the series will converge to and to find the interval for which the function is defined. So the geometric series is a summation k equals 0 to infinity x to the k, and it converges to 1 over 1 minus x, which is very similar to our a over 1 minus r, as long as the absolute value of x is less than 1. In this example below, we see find the function represented by the series and find the interval of convergence of the series of convergence. So our summation here is k equals 0 to infinity of x squared plus 2 over 3 to the k. And you can see the setup is pretty similar, except that our x function is a lot more complicated than it was in the given theorem. So the math will be a little bit more complicated, but we'll see it follows a similar pattern. What we need to do is make sure that our value of x, and in this case that would be x squared plus 2 over 3, absolute value is less than 1. And we would find that it's convergent to the same idea, except again our x value would be x squared plus 2 over 3. So we just need to plug and chug our x value from our summation into these two ideas to be able to find, one, the interval of convergence, and two, the function that it converges to. So starting with the interval of convergence, because we should probably make sure that there is an interval of convergence before we take the time to find a function, we have x squared plus 2 over 3, absolute value is less than 1. Looking at this function, we see that we have an x squared, which is positive, a plus sign, which is positive 2, all divided by a positive 3, leading us to just a positive number no matter what we do on this side of the equation. So in other words, our absolute values aren't really necessary. So now simplifying, we multiply both sides by 3 and subtract 2. So x squared is less than 3 on this side, minus 2 is 1. Now taking the square root of both sides, we recall we have a plus and minus whenever we take a square root, so we end up with x is between 1 and negative 1. So our interval of convergence so far is negative 1 to 1. We do need to double check that our endpoints are either included in the interval or not included in the interval, and to do that we'll plug the endpoints back into the original summation and see whether or not that summation converges. So our endpoints are negative 1 and 1, but we're squaring them when we put them into our summation, so we can just check 1, because no matter what we'll get the same result. So we have the summation k equals 0 to infinity, and plugging in negative 1 squared plus 2 over 3 to the k, we end up with the summation k equals 0 to infinity of 3 over 3, which is better known as 1 to the k. We're essentially summing up 1 forever, so this is divergent. And we've also broken the rule that x is less than 1, so either way, this is divergent. Neither endpoint should be included, and so we're going to use open brackets to be able to represent this interval. If endpoints were included, then we would change them to square brackets. But since neither endpoint is included, we're going to leave them as open brackets, negative 1 to 1. The next step is to be able to find the function this converges to, and for this we're going to use the 1 over 1 minus x. Here we have f of x is equal to 1 over 1 minus x, but in this case our x is more complicated. It's 1 minus that entire x function. Just to emphasize, we'll switch colors, x squared plus 2 over 3. Now we've got to simplify the function, so I'm going to multiply 3 over 3 here, and that will give me 1 over 3 over 3 minus x squared plus 2 over 3. I've got to distribute the negative, and that will give me 1 over 3 minus x squared minus 2 over 3. Multiplying the top by the reciprocal of the denominator, we have 1 times 3 over, and simplifying 3 minus 2 is 1, negative x plus 1. That leaves us with just 3 squared over 1 minus x squared, or negative 3 over x squared minus 1. You can choose either form of this, both of them should be correct. And so in summary, we ended up with a function f of x is equal to 3 over 1 minus x squared with an interval of convergence of negative 1 to 1. I hope you found that useful. Remember to pop into Pronto or the Hey Instructor or the email if you have any further questions on this video. I look forward to hearing from you.